Hi again, everybody. Thanks for following along. This is homework 10.3 that we're going through, and I'm actually doing the problems with you for you to follow along with. So this is problem 8. We're dealing with conservation of momentum. Okay? So we have a child in a boat. Okay? I'm actually going to draw a child in a boat right here. So there's our boat, and it's let's say it's in water. Okay, there's our water right there, and the child is standing in the boat, and they're gonna be standing here, and apparently they have some sort of package in their hand. Okay, it's just something with mass. All right, and so what they do is they throw the package out like that. All right, they propel it out that way. It's like a bullet in a gun being propelled out one end, and what's going to happen to the rest of the gun? It's going to move the other way. Okay, um, and so we want to find out. What do we want to find out? We want to find out, calculate the velocity of the boat immediately afterwards. All right, so it's the boat and the child because the child is in the boat, right? But the only thing that is left has been this package right here. All right, so we're going to call this package object 1. Okay, I put a 1 in there. Kind of hard to see. And the boat/child system, this is all going to be object 2 right there. Okay, so let's go ahead and write down our knowns, and we can solve for this. So the mass 1, that's the package, is 5.40 kilograms. Okay, what was the initial velocity of the package? Well, it's going to be 0, right? And in fact, it tells us that, assuming it was initially at rest. Well, what's the initial velocity of the boat and child? It was also at 0, right? It wasn't really going anywhere. The child was just standing there, ready to throw this package out. Okay, so the final velocity of object 1 is 10.0 meters per second. So if this direction is positive, then that means this direction right here has to be negative. So we want to find the velocity of the boat. So the final velocity of object 2, that is the boat and child. That's what we want to find out. Okay? Well, once again, we can say that the initial momentum of the system equals 0. That also equals the final momentum of that system. All right? The only difference is, initially, everything is at rest and nothing is moving. Finally, things are moving just in opposite directions. So the package is going to be moving out this way. The boat/child are going to be moving out this way, and that's going to be a negative direction right there. Okay? So 0 equals the final momentum of the system. Well, that's going to be momentum final of 1 plus momentum final of object 2. All right? We want to find the final velocity of 2. So we're going to get it all by itself. Actually, in previous problems, we expanded this out and then moved final momentum of the other one over. But I'm just going to subtract it over right now. So I'm going to subtract over final momentum of 1. So it's going to be P final of object 1 equals P final of 2. They have to be moving in opposite directions in order to cancel out to 0, which is what the initial momentum was. Okay, now we can expand these out. So final momentum of the boat and child. Oh, you know what? I didn't write this down. Darn it, I didn't. Mass of the child 2 is 26.0. All right, and the mass of the boat 2 is 55.0. Both of those are kilograms right there. So we're going to say the mass of 2 total is the sum of those. So 55 plus 26, that's what, 61, so 81, right? 81.0 kilograms. That's what we need, okay? So we have the total mass of 2, the total mass of 1, the final velocity of 1. We need to solve for the final velocity of 2. All right, let's expand these out here. So we have negative mass 1, final velocity of 1, equals mass 2, the whole boat child system 2, times final velocity 2. All right, we're solving for that final velocity of 2 right there. So, oh, you know what? I accidentally didn't mean to do that. I put the 2 as a superscript. It looks like it's squared. Final velocity of 2 down at the bottom right there. That's what I wanted to do. Okay? Well, let's divide by mass 2. So the final velocity of 2 is going to be negative m1 v final 1 divided by mass 2. That's going to be 5.40 times, what's a v final 1? That's 10 meters per second, right? 10.0 meters per second in the positive direction. Oh, and I forgot to put the minus sign out front. Okay? Excuse me. Divided by the mass of 2. The mass of 2 is at total 81.0 kilograms, right? 81.0 kilograms. And so the final velocity of 2 is going to be negative, right? And it has to be because 2 is going to be moving in the opposite direction as 1. That's 5.40 times 10 divided by 81. 0.6. How many sig figs? 67 meters per second. It's the final velocity of the child in the boat. Because if you're in a frictionless system, now water isn't totally frictionless, but it's almost. If you're in a boat and you throw a heavy package out, or even if it's not heavy, but if it has some mass, your conservation of momentum is going to mean that you're going to have to push back the opposite direction. All right, so that's example 8 in our conservation of momentum homework 10.3 problem set. So thanks for following along. I'll see you on the next one.